Hello everyone, welcome back. So in the last video we talked about interpolation error and we found a explicit formula for it which came from Cauchy's theorem. So let's write that down. So we could write f of x minus Pn of x absolute value m plus 1 xi, where xi belonged to the same interval as x but it was undetermined, n plus 1 factorial, and then you had x minus x0, x minus x1 up till x minus xn, because these factors were making sure that the error is 0 at the nodes. All right, so this was the formula, and we said that we cannot calculate xi explicitly for every x, but what we can do is that we can find an upper bound for this right hand side, and that is what we will do right now with a precise example. Okay, so let's check this example. So we will do the famous old one that we have been doing for a while. So let's say f of x is equal to cos x with the nodes minus pi by 4, 0 and pi by 4. Okay, so now I can see is that my nodes are x0 is equal to minus pi by 4, x1 is equal to 0, and x2 is equal to pi by 4. Okay, so I have three nodes, so my interpolated polynomial will be P2. Okay, now I want to explicitly calculate the right hand side of the error formula. So what we can write is that f of x minus P2 of x is equal to f3 of xi, because my n is 2 here, f3 of xi by 3 factorial, which is 6, and I'll have x plus pi by 4, x minus pi by 4 into x. Okay, so f3 here means that this is the third derivative, and if you calculate three derivatives of this, cos will give you minus sign will give you minus cos, and then a plus sign. So the third derivative f3 of x will be sine x. So what I can write is that sine xi by 6, and you have x into x plus pi by 4, x minus pi by 4. Okay, now I want to calculate the interval. I want to calculate the maximum of this whole thing in the interval, say from minus 1 to 1, because all my nodes are in this interval. Okay, this interval will be given in your problem. So the idea here is that, I mean, xi belongs to this interval, and all of these three nodes also. Okay, because pi is equal to 3.14, so 3.14 by 4 would be less than 1. All right, so okay, so let's take this interval, and now I want to focus on something. I want to emphasize that if I want to find the maximum of this function, then I have to find the maximum of this and the maximum of the this one separately. Okay, so for sine function, and maximum in this interval to be more precise. Okay, so for sine function we know that sine 0 is equal to 0, and it keeps on increasing up till pi by 2. And if you remember pi by 2, it's 3.14 by 2, which would give you 1.57, which is out of my interval. Okay, so minus 1 plus 1 will be somewhere here. Okay, so the maximum value, max, of sine xi in this interval from minus 1 to 1, xi belongs to here, Okay, what I mean is that if I can keep increasing the value of xi, the value of sine will be increasing up till pi by 2, but my interval stops at +1, so the maximum value I'll get for sine is at +1. I hope this is clear. Please think about it. If it were cos, then I would have used cos 0 in this interval, okay, but as this is sine, it will be sine 1. So the maximum value of sine xi in this interval will be sine 1. Okay, and if you want to calculate this value exactly, you can do it in the computer, that's or your calculator. So this pink part, this one is done. So this is nothing but sine 1 by 6. Okay, now let's check the green part. So I have to find the maximum value of let's check the green part from here and write it in black. So the maximum value of this is x into x plus pi by 4, x minus pi by 4, and I have to find the maximum value of this at the interval, I mean in between the interval -1 to 1. Okay, so for convenience, let's try to write it explicitly. So the first term will be x cubed, then the second okay, there's a shortcut way to do it. Let's do this first. This is nothing but x square minus pi square by 16. Okay, then this would be nothing but x cubed minus pi square by 16 x. All right, so let's give this function a name. Let's call this w of x. Okay, so I want to find the maximum value of w of x. If you're given a function, how can you find the maximum value of that function in an interval? You did it in your high school. So what I mean by high school is college. I mean in your HSC class or A levels, or maybe before that. If you want to calculate the maximum value of a function, what you have to do is you have to make the first derivative equal to 0, right? The idea is pretty simple, is that the maximum value occurs like this, and at the maximum point the tangent is like this, and the angle is 0 with the line parallel to the x-axis, and that gives you tan 0. So that gives you 0. So the first derivative at this point is equal to 0. That is why you do that, but it is the same for the minimum, and then you have to check with the second derivative, right? F double prime of x, or if it is w, then w double prime of x. If that is less than 0, then it's a maxima, max, and then if it's greater than 0, then it's a minima. All right, so you all know this, I hope so, and if you have forgotten it, please revise this in basic calculus. So what we have to do to find the maximum value of this, we have to calculate w prime of x, and if you do that, that would be nothing but 3x squared minus pi squared by 16. So what do you have to do? You have to turn the first derivative into 0. I mean, you have to solve the equation and find the value of x, and if you do that, first derivative is equal to 0, then you get two solutions, and that is okay, 3x squared is equal to pi squared by 16, and this implies x is equal to plus minus pi by 4 root 3. All right, and I think you can guess it from the form here that it is less than 1, so it is in my interval. But there is something to notice here, and I'll explicitly say it to you now. That is, let's say I am in this interval -1 to 1, and this is my w of x. I'm plotting it. say this is the maxima. Okay, so you will find that the first derivative is 0 here, but that doesn't necessarily guarantee you that this is the maximum value in this interval. Let me give you a counter example. A counter example will be if it keeps on going, and this is your one line, then it can keep on going like this. So you can see that in this okay, let me use a different color, red. In this interval, this point is the maximum value, right? But if you are calculating first derivative is equal to 0, you will just get this point, not this one. Not this one. You will not get this, because the value of the derivative at this point is not equal to 0. So what you have to do is that you just not only have to check it at these points where it's the extremum point, you have to check it at the corners as well. All right, I hope that it is clear to you. So corners, by corners I mean the value of the extremum points of the interval. All right, so what we have to do is that to find the maximum value of w of x, we have to check the value w of x at x is equal to plus minus pi 4 root 3, also at plus minus 1, because I have to check at the corners. By corners I mean the interval. You have to check at these points as well, because of that counter example that I gave you. Okay, so rather than doing a second derivative again, I can just check these points, because I mean the corner points won't even give you the first derivative equal to 0 equation, right? So the best way to do this is to form a table. So what you do, 1, 2, 3, 4, that's all I need. This is x and this is your w of x. You plug in these 4 values, minus pi by 4 root 3, then this is pi by 4 root 3, then you have minus 1, then you have 1. Okay, if you calculate the value of w of x, please remember this is w of x, not w prime of x. You're calculating the maximum of w of x, and if you calculate that, this would be 0.186, this will be minus 0.186, this will be minus 0.383, and this will be plus 0.383. Okay, so I can clearly see that the maximum value is at plus 1. So our example that we drew a few moments back was precisely saying this. All right, so we have found the maximum value of w. So what we have to do here, so separately we have found the maximum value of this and the maximum value of this. So the maximum value of this error has been found, and which is nothing but, so the maximum error is equal to sine 1 by 6 into 0.383. All right, so we have found it out. You can calculate the explicit number with your calculator. So the idea was pretty simple. I will use the Cauchy's theorem. And then I'll try to evaluate this. So I'll evaluate this pink part and this green part separately and try to find their maximas. So as it was simple because it was a sine function in the pink part, so I could just guess it without even doing the calculation. So if it were a polynomial, then we have to do a first derivative equal to 0 and check the corner points for this function as well. I hope it is clear. If rather than being a cos x, it would have been if it were like a polynomial, then you have to do the same thing that you did for this green part for this pink part. You have to check the first derivative is equal to 0 points and the corner points. All right, but it was sine function, so it was very easy for us to explicitly find out which one is the maximum point without even doing any calculation. All right, so what you do is that you define this function to be something like w, and you calculate the w prime, the first derivative, equate it to 0, find the points, and then form a table like this to get the values. But the important lesson here was that not only I have to check not only at the points where first derivative is equal to 0, but we have to check at the corner points because of this example, right? Because this is not the maxima, this is the maxima in this interval. All right, and we have explicitly seen that plus 1 is the maximum value. And so we have found the maximum possible error in this -1 to 1 interval. So that's how you calculate the maximum error. So Cauchy's theorem maybe practically is not that not that efficient because you don't know xi, but you can precisely say what can be the maximum possible error. All right, so this is the application of Cauchy's theorem. So you will be given some problems to solve in your assignments, and I hope that will help you understand this thing better. Okay, thank you so much.